Meteorological observations are critical for a wide range of things. Weather forecasts, preparation for severe events, planning for aviation, for climate and weather research, and a host of other types of activities.
Meteorological instruments and observing systems are needed because we want to be able to understand the phenomenon that we're studying. Why do we want to understand that phenomenon? For several reasons. For one, it can become ground truthing or the initialization field for a model. We can use it to understand anything from, say, road weather to space weather and be able to respond to impacts of that particular phenomenon. That crosses many boundaries, from hurricanes to tornadoes to geomagnetic storms. If we have the instruments and the measurements and the observations, then we're much better prepared to assess the impacts of a particular event. What we know about a particular phenomenon is grounded in observation. We can model it, we can diagnose it in a number of ways, but the ground truthing comes with observation. And a lot of the research projects that are going on today are to do just that, are to ground truth satellite imagery, to develop better algorithms so that the relationship between the instrument response and the natural response, that relationship is robust. In the end, what we really want to know is whether our measured value is as close as it can be to the true value.
Selecting a suitable instrument based on its characteristics is critical because you want those characteristics to match up with the phenomenon that you're trying to measure. So it wouldn't do any good to use an instrument that's really great for large-scale observations for something that happens over a scale of a meter or over a time frame of a few seconds, when it might instead have an observing footprint of a kilometer and a time horizon of minutes. So when you're selecting an instrument or an observing system, there are some important parameters that you need to think about. You need to think about the response time of the instrument, how quickly it can make the measurement. You need to think about its spatial resolution, what area it's going to measure over. Calibration is essential to understanding an instrument and an observation. By calibrating an instrument, you reveal uncertainties and errors that may be inherent in the measurement. And without knowing those, you don't actually know how good the measurement that you made is. Calibration is the process of correlating an observation from your instrument with an observation from another instrument of a known quality. And normally we call those things standards. A well-designed research project must incorporate calibration throughout, so before, during, and after the research or the data gathering is being done. As someone who spent a large part of their career designing, building, and using instrumentation, I think it's really important that we understand basic measurement science, instrument characteristics, precision, and accuracy to make the best possible measurements for understanding the environment.
It is important and necessary that we understand the principles behind instrumentation and measurement, because it's the basis of our understanding of the phenomenon that we study. It's the basis of understanding science, and it's the basis of getting to the truth, or as close to the truth as we can get.